All right, so today we're going to tackle a concept that sounds super simple, but honestly, it hides this fascinating reality bending truth: quantum spin. It's a term you hear thrown around all the time, but what it actually means is one of the strangest and, frankly, most profound ideas in all of physics.
Okay, so let's just dive right into the central puzzle that stumps pretty much everyone. When you think of spinning, you probably picture a top or a planet or maybe a basketball in your finger. But here's the thing: electrons aren't little balls. For all we know, they're point-like. They have no physical surface to rotate. So, how can something spin if there's literally nothing to spin?
To get to the real answer, we first have to completely dismantle the myth. We're going to start with that common mental picture most of us have for an electron, the one that makes perfect sense in our everyday world, but just completely breaks down at the quantum level.
I mean, it's an intuitive and simple image, right? A little marble of matter just turning on an axis. It's a helpful starting point, and it's totally how early physicists first pictured it. But as we're about to see, quantum reality is so much weirder and way more interesting than just a tiny spinning ball. And here we have it, the core conflict. On one side, you've got our comfortable, classical idea of a spinning basketball. On the other, the totally mind-bending reality of something called a quantum field. Our journey today is all about understanding how we get from one to the other.
So let's really look at why that spinning ball idea, as neat as it is, completely falls apart when you look closely. And I don't mean it's just a slightly wrong picture. I mean it leads to a situation that is physically impossible. Physicists actually did the math on this. They took the measured magnetic field of an electron and its incredibly tiny estimated size, and they tried to calculate how fast its surface would need to be spinning. The result? Well, the result was a number that revealed a deep paradox, one that would smash a universal speed limit. Yep, the calculation showed that for an electron's surface to generate its known magnetic field, it would have to rotate faster than the speed of light. And as Einstein famously taught us, nothing can do that. It is the absolute cosmic speed limit. So right there, the spinning ball model is just dead on arrival. Okay, so if it's not actually spinning, what on earth is it? Let's try a brilliant analogy to build a new kind of intuition. This is going to help us shift our thinking from physical motion to something much more fundamental about, well, about perspective. Okay, imagine a camera on a stand and it's filming a room. The camera itself is turning, but the room, the chairs, the tables, all of it, they aren't moving at all. But when you watch the footage back, the whole room looks like it's spinning. The motion you're seeing isn't in the room itself, it's just in your changing point of view. So let's map this out. In our analogy, the camera is the electron, the room is space itself, and the rotating stand? That's your coordinate system. It's the mathematical framework you're using to describe things. The spin we measure isn't physical motion. It's simply how the electron's properties appear to change when we rotate our mathematical point of view. It's all about perspective. With that analogy in mind, we can now finally define what spin truly is at the most fundamental level. We're leaving the world of handy analogies now and entering the realm of quantum field theory, which is really our modern description of reality. This is so crucial. Spin isn't something an electron does. It's part of what an electron is. Asking what makes an electron spin is like asking what makes an electron have a negative charge. It just does. It's a built-in, unchangeable, fundamental property. Think of the whole universe as being filled with these invisible fields. An electron isn't a tiny speck in a field, it is an excitation of the field, kind of like a wave in an ocean. And spin is just a fundamental property of that wave. It's the built-in intrinsic angular momentum that this little ripple in the fabric of space-time carries with it. And here's the most amazing part. Back in the 1920s, a physicist named Paul Dirac wrote down this beautiful equation combining quantum mechanics and special relativity to describe the electron. And when he solved it, the property of spin just popped right out of the math. No one put it in. The universe was basically telling us about spin through its own native language, pure mathematics. Incredible. Now, this might all sound very abstract and philosophical, but this intrinsic property has massive concrete consequences. I mean, spin isn't some tiny esoteric detail. It literally shapes the entire material world around us. Spin is the reason matter doesn't just collapse into a single point. It's what dictates that no two electrons can occupy the same quantum state, which gives us the structure of the periodic table and, all of chemistry. It's even the basis for technologies like the MRI machines in hospitals.
Spin is truly fundamental to everything. And when we go to measure it, we find another purely quantum effect. Spin is quantized. You can only ever find it in one of two states, up or down. Nothing in between. This was famously proven by the Stern-Gerlach experiment, where they shot electrons through a magnetic field. Instead of getting a continuous smear on the detector screen, the beam split into exactly two distinct spots, a purely quantum result.
So finally, let's address the elephant in the room. If it's not really truly spinning, why on earth do we still call it spin?
Well, the name was coined way back in the 1920s, when that spinning ball idea was the best guess they had, and the name just stuck. By the time the true quantum nature was understood, it was already too deeply embedded in the language of physics to change. It's a perfect example of how our everyday words can be a really poor fit for the bizarre quantum world.
So, the next time you hear the term electron spin, you'll know what it truly represents. Not a tiny spinning top, but a deep, unchangeable truth about the very fabric of reality, a fundamental property that dictates how our entire universe is built. And it really makes you wonder, right? What other simple words are out there hiding an entire universe of complexity?